Hello, this is Mr. Wynn. Today's video will be about 6-4 nth roots. So you can read that. Talking about nth roots, you already know about square roots, but an nth root is any number kind of root. So it could be a third root, fourth root, fifth root, sixth root, 100th root if you wanted. That table looks a little confusing, so I'm going to teach you a different way. So say I wanted to take the square root of 32. Well, y'all know to break it down, so we're going to do a lot of breaking down here. I would do 2 times 16, 4 times 4 if I wanted to save some time, 2 and 2, 2 and 2. I circle my pairs. There's a pair there, there's a pair there. One goes outside, one disappears, another goes outside, another disappears, and this partner, that 2 has no partner. So that's really the same as 4 square root 2. So those are the exact same thing. Now, a square root has a hidden number that I usually don't see. We start writing it, but right inside that square root or outside it, above this thing is a 2, is an invisible 2. That's the reason why we circle pairs of 2. Now, let me jump to this harder one. The fifth root of 32. So instead of pairs of 2, or groups of 2, I should say, I'm going to find groups of 5. We still break it down the same. We find all the prime numbers, so 2 times 16, 4 times 4, 2 and 2, 2 and 2. Now, instead of finding pairs of 2, I find pairs of 5, or groups of 5. Well, that takes up all of these guys. Remember, only one of them goes out, everyone else disappears in that group. And there's nothing left to stay inside the square root, the square root's gone. That's why the fifth root of 32 is 2. That's what they're saying right here. The fifth root of 32 is 2. You could check that in the calculator, so let me show you the buttons. In the calculator, on the left side, you're going to press math. You can go to number 5. 5 is to pick any x, any root. Well, I'm going to put a 5 there. And inside, I'm going to put a 32. So the fifth root of 32 is 2, because 2 to the fifth power is 32. Remember, roots and powers cancel each other out. That's like the opposites, like adding and subtracting are opposites, multiplying and dividing are opposites, roots and powers are opposites. Here's some vocabulary. So that number right here, right above the square root, is the index. So there's a 2 there for square root, there's a 3 there for cube root, 4 there for fourth root. That tells us how many we need in the group. Then the radical sign is that square root sign they always use, and the radicand is the number inside. Oh, here's an example. Simplify. So this time I was nice. I told you it's a square root. I need to find pairs. Well, you break it down for numbers and letters. So I'm going to do the number first. 16 is just 4 and 4. Well, 2 and 2. 2 and 2. So there's a pair. One goes out, one disappears. There's another pair. One goes out, one disappears. So that's really 4 goes outside. Now for the y to the fourth, well, y to the fourth is really just y times y cubed, if you want. Y cubed is just y times y squared. And y squared is just y times y. Well, there are pairs of y's too, so one of them goes out, one disappears. Another pair of y's, one goes out, one disappears. So this is 4y squared. Now y'all know 4y squared times 4y squared is 16y to the fourth. Right? Now for the numbers, you're going to have to break it down like that. For the letters, it is a pain in the butt to write this and keep taking it down one at a time. This part right here, so there's a shortcut. So the shortcut is this. Just divide that number of the exponent inside for the letter and then by the index. So 4 divided by 2 is 2. That's why y2 came out. So here's another one, a little harder. We're taking the fifth root of 243, a to the 20th, b to the 25th. So for the number, we have no choice. 243 divided by 3, well, is really 3 and 81. Well, 81 we know is 9 and 9. Well, 9s are 3 and 3, 3 and 3. So I finished all the prime numbers for the number. I need a group of 5. Well, lucky for me, that takes out all of them. There's all 5. One goes out, everyone else disappears. And there's nothing else left over. a to the 20th. Instead of breaking it down to a times a to the 19th and a times a to the 18th, I'm going to say, well, 20 divided by 5 is 4. So a to the 4th goes outside, and that's gone. Now b to 25, well, 25 divided by 5 is 5. So I'm going to take this out. And that's my answer. Now if you want to check, you could go back to what we did in 5-1, the exponent properties, because 3a to the 4th, b to the 5th power, well, you distribute this exponent to everything inside. So 3 to the 5th times a to the 20th times b to the 25th. Well, 3 to the 5th, y'all know, is 243, a to the 20th, b to the 25th. So that's just checking. You do not have to do that. All right, so that's extra. All right. Now be careful when an even exponent inside the radical comes out odd. If it does that, you must use the absolute value sign. So here, I start out very simple. I'm taking the 4th root of y to the 4th. Well, there's only, I can divide. 4 divided by 4 is 1. So really, a single y comes out. I mean, if you really want to, you could break that up to y times y times y times y, circle all 4, 1 goes out, the rest disappear. Now, see how it was y to the 4th, it was even inside? On the outside, it's just y to the 1st power. Since that, I must put absolute value sign around it. That's my answer. Now, the reason why we do that is we don't know if y is positive or negative, the number is positive or negative, because we're taking the 4th root of a number inside. Well, what if y was negative, say, 2? If I do negative 2 to the 4th power, that's negative 2 times negative 2 is 4, times another 4 is 16. Or what if it was positive 2? 2 to the 4th power is also 16. So basically I'm saying if the number inside was 16 and we're taking the 4th power, how do you know if it was negative 2 or positive 2? Well, to be safe, you put this absolute value around that y or that number to always make it positive. All right, that gets us the principal root. Other side, the number right here is missing. If it is missing, it's automatically a 2. So we're trying to find pairs. Well, this is 6 times 6. Well, that's 2, 3, 2, 3. So I have a pair of 3s, 1 disappears, 1 goes out. I have a pair of 2s, 1 goes out, 1 disappears. So that's really 6. And y to 6, I just do the shortcut. 6 divided by 2 is 3. Now again, it went from even number inside to odd number outside. So I need absolute value sign on that. That's our answer. Now also, if the number is nice, like 36, you could save time and just take 6 out, because 6 times 6 is 36. But you always have the option of breaking it down. All right, and the last part is be able to approximate radicals by using a calculator to find the decimal estimate. So sometimes decimals are okay. Just use the calculator and just round it. Do 2 or 3 decimals. I'll do 2 for now. So for example, we have a problem here. C equals 5/5 root of b squared. What's they say? C is the number of collisions, B is the number of bicycle riders at the intersection. Estimate the number of collisions, so find C if there are 1,000 bicycle riders per week. So we know B is 1,000, so C equals 5 root of 1,000 squared. Well, use a calculator for that. So remember in the calculator, you go to math. We're going to go down to number 5. We're going to put a 5th power out here. Inside we'll do 1,000 squared. The answer is 15.849. Let's say 15.85. So C equals 15.85. So if there are 1,000 bicycle riders at an intersection, expect about 15 accidents or collisions, crashes. That's it. All right, here's a problem for y'all. Simplify the following. There's the answer. If you can do that, you should be fine in class. Again, this is Mr. Wynn. Thanks for watching. See you in class.